Okay, so now I'm going to show you how to use the ANDI, OR, XOR, or XORI operators, or whatever you call them. These are really similar to the shifts. They only work bitwise, so they work with every bit within a number. So let's give an example. Let's go to my notes here real quick. Oops, so here, go here. So we have three different operations, AND, OR, and XOR, right? Meaning when we have AND, there's going to be 0 and 1 is going to be 0. 0 and 1 is going to be 0. 0 and 1, again 0, but 1 and 1 is going to be 1. If we do the same with OR, it's going to be just whenever we have 1. So 0 and 1 is going to be 1, 1, 1, 1. Again, here, and this one is going to be different. It's going to be whenever we have a pair of the same numbers, it's going to be 0. But if we have a non-pair, it's going to be just 1, right? So they work the same in basically in assembly. If we go back to our program here, we have the same numbers here. Just, oops, I forgot, it's 914. So in this case, we have the same numbers, and we can do the operations. So for example, AND x1, this is where we save it, so we're gonna do x3 for example, and then let's take the actual things we want to show. This will be saying that basically whatever x3 is going to be equal to the operation of x1 and x2. So in this case, if we go and take a look at the thing we did here, this is basically going to be 1, 2, 4, 8. It's going to be basically 8. The result of this operation is going to be 8. And we can take a look at that. We can run debug. No, I forgot to just do a nup. Run on debug. We can do integers. Add basically our numbers. Pretty simple. This is an E because it has a decimal, of course. And now we can do an AND operation. And the AND operation is going to be basically, as we said, it's going to be just 8. If I'm correct, 1, 2, 4, 8. It's going to be 8. So x3 is going to turn out to 8. As you can see, it turned into 8. And that's pretty much how it works. If we did an OR operation, right? The OR operation would take this 2, right? And it would turn out to be 8, 4, so 12, 14. This is going to be 15, right? So 15 in hexadecimal, I think it's F, if I'm not mistaken. So let's do and check it out. Again, we're going to be checking out x3, which is an important one here. And x3 is going to be F, as I said. Because it has a decimal, of course. And if we do XOR, it's going to be 1, 2, 4. So 6 is going to be 7, and here's a decimal. So we can take a look at that. XOR, integer, close this. Again, I don't know why I closed that. So we can do this one, and then we can take this one. And this is going to turn out to be, what did we say, 7, I think? Yeah, 7. And that's pretty much the concept. That's pretty much it. The difference between add and I is basically and immediate, meaning that if we do an and immediate, we would have to use an integer here instead of a thing. So in this case, if we just wrote 14, we would have the same result. So let's take a look at that. We should be getting at the end 8. So it's gonna be the same thing. You see? Rather with immediate we just write actual numbers, and with non-immediate we write integers. So it'll be like something like that with and normally. So that's pretty much it. I hope that you understood this, and yeah,